Hi everyone, good morning to all of you. Today's concept is state chart diagram. So the state chart diagram is one of the topic of advanced behavioral modeling. Right. So in this advanced behavioral modeling, we have this is the first unit. Previously we have discussed about the topics like event and signals, process and threads, time and space, state machine. Now we are discussing about state chart diagram. All these are all these are advanced behavioral modeling. The state chart diagram is one of the nine five diagrams which models dynamic aspects of a system, which means it will do some actions, right? So the other five diagrams which models the dynamic aspects of a system are use case diagram, activity diagram, interaction diagrams like sequence diagram and collaboration diagram, and lastly state chart diagram. All these are models the dynamic aspects of a system, which means it models the actions or some behavior on the system. So now we will discuss about state chart diagram. The state chart diagram also called a state transition diagram. It is also called a state diagram. So what is a state chart diagram means? So in this state chart diagram, it will discuss about state machine, how it will discuss about state machine and different state of an object that undergoes during its lifetime, which are controlled by events. So what is a state chart diagram? In this state chart diagram, it will discuss about state machine. State machine. The state machine is a machine which defines different states of an object. Right? It defines different states of an object, and these objects are controlled by an events. We discuss. So the contents or features in this state chart diagram is simple states, composite states, transitions, events, and actions. So what is a simple state? Any state which has no substates is known as simple state. It will explain simple behavior, whereas composite states contains substates. So it explains about the complex behavior of a system. So what are transitions? Transitions is a relationship between the states. This transition is responsible for changing one state to other state. So in this state chart diagram also includes events and action. Events is a significance or specification of occurrence, which time and space, as I told you earlier. So action is a executable atomic execution, which means this action is cannot interrupted by other events, whereas activity is a set of actions. This activity is a non-atomic execution, which means it can be interrupted by other events. Okay, these are all the terms and concepts. These are all the concepts involved in Shadesar diagram. These topics are also, these features are also present in state mission. If you read state mission, if you write here, those are good. So if you see, what is a state? Generally, what is a state is a condition during lifetime of an object which satisfies some condition. So how the object undergoes, how the state will change from other states. So by when satisfying a condition, so by an activity, then it will go from one state to other state. So that's why state is a condition during lifetime of an object which satisfies some condition. Okay, these states are simple state. A simple state is a state which has no substates. Composite state is a state which is having complex behavior and it also contains the substates. Action means atomic execution. So anything is an action, like calling an operation is an action, sending a signal to it is an action, creating an object is an action, destroying object is an action. These are atomic execution, which means independent execution, which means no other event interrupts when other action is performed. Transition is a relationship between two states. So it is responsible for changing from one state to other state. Event is a significance of occurrence. which having some time and space. And activity means it is a set of actions. So it is a non-atomic execution. It can be interrupted by external event. So what are the common modeling techniques of state chart diagram? So these are the common modeling techniques of state chart diagram. Generally, state chart diagram is useful for modeling reactive objects. To model reactive object, we need a context of a state machine. After that, we have to choose initial and final states. Then we have to decide on stable state of an object. Stable state of an object by considering conditions. Then we have to decide on events that takes place in these events. So then we have to consider about transitions, which uh, which is the relationship between two states, which interconnects two states. Then by simplifying a mission, we have to consider the ways for simplifying a mission by substates using some fork and join states. Okay. Uh, Next, you can trace the state mission using manually or by using tools. So this is the state mission which is accepting the strings like the strings which are in this format. So angular brackets inside a string, any kind of string, and also any length of the string. After closing the angular bracket, these type of strings are accepted in this state mission. As I told you initially, this state mission is in waiting state. So this is the start. This is the start initial state. Initially, it is in waiting state. The state machine. So whenever it receives a less than character, it will change state from waiting to getting token. Whenever this getting token state will receive a greater than character, it will change its state from getting token to getting body. The main objective of this state machine way is it accepts these types of strings. So angular bracket string less than symbol between string any kind of string closing the greater than angular brackets and any length of the string. These three types of strings can be accepted in using this using this state machine. If you see when C not equal to here, when you see in waiting state, when C is not equal to less than symbol, then it will be written false and it still will be there in waiting state. Whenever the C character is not equal to greater than, it will append the string. Here we are append the string between the angular brackets. So whenever C not equal to semicolon, it will append the strings. Whenever it receives a semicolon, it will go again. It will go to waiting state. There is no final state in this state mission. Only initial state will be there. This mission accepts the strings which are in these type of strings. Okay, so this is the forward engineering. We can do forward engineering using the state machine. So if you see, this is the class is a Java program. The class is a message parser. So we are implementing a switch case for this state machine. For this state machine, we are implementing the switch case. Initially, it is in waiting state. Whenever it receives, when character is equal to less than symbol, the state will change from waiting to getting token, and then we have to create a buffer to both token and body. So next, whenever it will comes to getting token, whenever in this getting token state, whenever it receives a greater than symbol, it will change its state from getting token to getting body. So whenever and whenever it is not received greater than symbol, it will append the string. Whenever it is present in getting body string, whenever it receives semicolon, again it will goes to waiting state. If it does not receive semicolon, as long as it does not receive this semicolon, it will be append the character into its buffer. So this is in this way we will do forward engineering. Forward engineering is nothing but getting code from the model. So we have get the code from using this model. We have get the code this code. Okay, so reverse engineering nothing but creation of reverse engineering also possible in state machine. That is creation of model from code. Creation of model from code. Thank you. It's about state chart diagram or state transition diagram or state diagram. Thank you.